Alright, so to find the angles on the exterior of a circle is what we're going to talk about now. So to find the angle on the exterior of a circle, all we're going to do is we're going to find the measure of the big arc minus the measure of the small arc and divide it by 2. And that will give us the angle measure. So for here, if you have 2 secants and we're looking for angle A, so that's this angle right here, which we can see is on the outside, we're going to take the measure of arc CE, minus the smaller arc that's intersected, so BD, and then we're going to divide by 2. If we have a secant and a tangent, we're going to do the same thing. We're looking for this exterior angle, angle A. And so to do that, we're going to subtract the bigger arc, which is BD. So arc BD minus the smaller arc that it intercepts, which is arc BC. And then we're going to divide that by 2. And then here, when we have 2 tangents, we're trying to look for this exterior angle A. So we're going to take the bigger arc. Now we can see that this arc is a major arc because it's going to be bigger than half the circle. And so remember, with the major arc, we have to use 3 letters. So that's arc BDC minus the smaller arc, which is arc BC. And again, divide by 2. Okay? So now we're going to do some practice problems with that. Alright, so the first one is we want to find the measure of angle KLM. So KLM, again, is this angle here. It's the exterior angle. So we want to do the big arc, which is 140 degrees, minus the measure of the smaller arc, and divide that by 2. So 140 minus 66 divided by 2, and you end up with 37. So we know the measure of angle KLM is equal to 37 degrees. So that's the angle. So this angle here is 37 degrees. So we look at our next one. We want the measure of angle ABC. So we can see we can trace from A to B to C. So again, this is the angle here, and we're looking for the one on the exterior. So now we know we have to do the big arc minus the small arc equals divide by 2 equals the angle. So I know the small arc is 62. So something minus 62 divided by 2. But as of now, we don't know what arc DA is, which is the bigger arc. But we know that if AC is 62 and if CD is 88 and the entire circle is 360, so we can do 360 minus 62 minus 88, and so we know that this arc has to be 210 degrees because all 3 of these are going to add up to 180. So then we know that's 210 minus 62 degrees divided by 2, and when we do that, we end up with 74. So we know the measure of angle ABC is equal to 74 degrees. The next example, we want to find the measure of angle PQR. So again, this exterior angle. So we know the big arc minus the small arc divided by 2 is going to equal the angle. So we know we got to divide by 2. We know the big arc PSR is 313. But they haven't given us the small arc. But again, if we know the entire circle is 360 and PSR took up most of it, and then we're just PR is what's left, we do 360 minus 313, and we end up with 47. So our PR is 47 degrees. And then we're going to subtract those two and divide by 2. And we end up with 133. So then we know the measure of angle PQR is equal to 133 degrees. And the next question, we're looking for angle BCD. So again, hopefully you can tell that this is the exterior angle. So we know we got to have the big arc minus the small arc divided by 2. So the big arc that's intercepted is AE, so that's the 67 minus, and then we need BD, which they didn't give us. But as we can see that here, AC is actually a diameter. So that means it splits the circle in half. So that means all the way from A this way all the way to B is 180 degrees because it's a semicircle. And we know we have 67 and 94. We can figure out what BD is by doing 180 minus 67 minus 94. And we end up with BD as being 19 degrees. So then we can do 67 minus 19 divided by 2, which we get 24. And so now we know the measure of angle BCD is equal to 24 degrees. Okay? And so if we look at number 14, this time we're not looking for an angle, we're actually looking for the arc. So we're looking for arc SW. Okay, so there's a couple ways we can do this that we can think of, but we can see we have the exterior angle. So again, if we know the exterior angle, which is 40, is equal to the big arc minus the small arc divided by 2, we can plug in what we know, because we know that's the big angle that we're missing. So if I can have that 40 degrees is equal to the big angle arc, which we don't know, minus the small arc, which is 75, and then we're going to divide by 2. So now we have an equation that we need to solve. So here I'm going to multiply both sides by 2 to clear the fraction. So we're left with 80 is equal to x minus 75. Again, remember those 2's cancel. Then we're going to add 75 to both sides. And we end up with 155 is equal to x. And so x is SW, so we know this is 155 degrees. So the measure of arc SW is equal to 155 degrees. So now we can work backwards. If we know the exterior angle and we know one of the arcs, we can find the other arc. And our last example, we want to find arc QU, the measure of arc QU, which is here. And hopefully you can see that that's the big arc. So we get 35, because that's the exterior angle, is equal to the big arc, which we don't know, minus the small arc here, which is intersected 46 degrees, divided by 2. And so now we just go ahead and solve this. So we're going to multiply both sides by 2. And then we end up with 70 equals, 2's cancel here, x minus 46. And then so we're going to add 46 to both sides. Is equal to 116 equals x. So that means we know that the measure of arc QU is equal to 116 degrees. And with this, you can always verify to make sure you work. Once you find the arc, plug it in, the big minus the small divided by 2, and make sure that you actually get 35. All right, and that's it.